Hello friends, this video on equilibrium part 8 is brought to you by examfear.com. No more fear from exam. Before watching the video, please make sure that you have watched part 1 to part 7. So till now we have learned equilibrium concentration in an aqueous system or a system which has liquids. But if you want to find the concentration in terms of pressure, because the last example also we have solved, it was all gaseous, right? We considered gas as the liquid and then we had moles per liter concentration. But what if we want to find the equilibrium concentrations in terms of pressure? So let's see this approach which helps us to find equilibrium constant in terms of pressure. So if you see, for reactions which we have which has gases involved, it is more convenient to express the equilibrium constant in terms of partial pressures rather than the molar concentration. Till now we have been using m or moles per liter, right? But for reactions which involve gases, it is convenient to write this equilibrium constant in terms of partial pressure, and that's what we'll do. So let's suppose the reaction I have A plus B is equal to C plus D, and all are gas. So in this case, the Kp will be what? The pressure of C to the power C, pressure of capital D to the power small d, pressure of A to the power small a, pressure of B to the power small a. So if you see here in this case, this is similar to what we had earlier. Earlier, what we should say is in terms of molar concentration, we should write concentration of C to the power C, concentration of D to the power D, concentration of A and B, concentration of A to the power small a, concentration of capital B to the power small a. This is what you should write for Kc. But now I am trying to write in terms of partial pressure, and this term now will be called Kp because we are using partial pressure here instead of molar concentration. And there is a relationship between Kc and Kp. So if we have Kp, we can easily find Kc, and other way around is also true. So if we want, we can actually derive this. Kp is equal to Kc RT to the power n. See, Kp is this value. So P is equal to, we know that, n RT by V, the gas loss. So Pc I can write as nothing but n RT by Vc, right? Nc to the power C. Pressure by D will be what? Moles of D, RT by volume of D, divided by pressure of A will be what? Moles of A, volume of A, RT by to the power A. And this pressure by B will be what? Moles of B, volume of B into RT to the power D. So if you see, moles per volume or per moles by volume is what? The molar concentration. That will be what? My concentration of C to the power C into RT to the power C, right? Because I just took this out, because N by V is nothing but concentration. This was for C. Now for D, D will be what? Concentration of D into RT to the power, here it was D, so it will be D and it will be D, correct? Divide by moles of A by volume of A is what? Concentration of A to the power A and RT to the power A, and it will be moles of B by volume of B will be what? Concentration of B to the power small b, RT by small b. So if you see this, if you take this factor now, it will be C to the power C, D to the power D, A to the power A, B to the power, capital B to the power small b, into RT. If you take constant, it will become C plus D minus A minus B, correct? And what is this value? This thing is nothing but my Kc, RT, and this whole thing is nothing but C plus D minus A minus B is nothing but delta n, that is change in moles of gas. Thus you can see that Kp is nothing but Kc RT to the power n. Correct? Easy to understand? So Kp is a very critical equation. Kp is equal to Kc RT to the power n. Please understand this. And how we got this was Kp was nothing but partial pressure of C to the power C, partial pressure of D to the power D, partial pressure of A to the power A, partial pressure of B to the power B. So what we did was here, partial pressure is nothing but nRT by V. That is, for C it will be partial pressure of C will be nothing but concentration of molar number of moles of C into RT by number of volume of C. N by V is nothing but my C, concentration of C. ND by VD is nothing but concentration of D. Na by Va is nothing but concentration of A. Nb by Vb is nothing but concentration of B. And this RT we expanded. We solved it, you get this value. This is nothing but Kc, and this becomes RT to the power delta n. Correct? So if you see for this equation, let's suppose 1, this equation is 2. For equation 1, my Kp will be Kc RT to the power delta n. What is delta n? This is 2 minus 1 minus 1. That is delta n here will be 2 minus 2, that is 0. In this case, Kp will be equal to Kc. Let's take this example. So here Kp will be, this is 1, this is 2. Kc RT to the power delta n. Delta n is what? Here we have 2, here we have 3 plus 1, 4. So 2 minus 4 is minus 2. So delta n will be minus 2. Please note delta n can have positive or negative value both. This will be my Kp. Just application of the formula, but derivation of the formula is this. In exam, you don't have to derive every time. You just use the formula which we have derived now. Kp is equal to Kc RT to the power delta n. Just remember this formula. Kp is equal to Kc RT to the power delta n, where Kp is nothing but my equilibrium constant in terms of pressure. Kc is nothing but equilibrium constant in terms of concentration. Let's take some example. For the equilibrium, 2NoCl gives 2No plus Cl2. The value of equilibrium constant Kc is this value at 1069 Kelvin. We need to find the Kp at this temperature. Once again, let me remind you, when this Kc was given, the temperature was given and this equation was also given. So both has to be defined, or both has to be given to give a value to this Kc. Because if you change this temperature, this value will change. If you change the equation by multiplying or dividing by some number, the Kc will change. Both has to be there. So anyway, let's find the Kp value. So Kp is nothing but Kc RT to the power delta n. Kc is given, RT something we know, delta n something we have to find. So delta n is nothing but number of moles of gas, you can say, or number of moles of product minus reactant. So in this case also, we ignore the solid part, ignore the solids, pure solid, pure liquid thing, right? Because for them the value is constant. It does, I mean, this pure solid, pure liquid thing, they don't even take part in Kc. So why do we need to count that? So here the number of moles of product is what? 1 plus 2, 3, and for reactant we have 2, that is equal to 1. So delta n is 1. So let's put the value. So Kp will be what? Kc, that is 3.75 into 10 to the power minus 6 into R. R here is 0.0831 in T is what? 1069 Kelvin. Please note, temperature has to be in Kelvin. If it is in Celsius, please convert that in Kelvin. To the power delta n, that is 1. So if you solve this, you get 0.033. Since there was no unit for this, there will be no unit for this. We'll take some examples where we have unit, so we convert that into Pascal actually, moles per liter. Anyway, since this Kc didn't have any unit, so Kp will also not have any. Find out the Kc for each of the following equilibrium from Kp. So Kp is given, we have to find Kc. So let's find delta n first for both the equation. So in this case, delta n is what? 1 plus 2, 3. 3, this is 3 minus 2, that is 1. 3 minus 2, that is. In this case, delta n is what? 1 plus this solid we can ignore, will not take this. And this also will not take. Delta n will be 1 minus 0, that is. So in both cases, delta n is 1. So let's try to solve the question now. The first one, we have the formula Kp is equal to Kc R to the power delta n. We know the value of Kp, that is this value, 1.8 into 2 to the power minus 2 is equal to Kc into R. R is what? 0.0831. T is what? 500 Kelvin. Delta n is what? 1. You solve this, you get Kc as 4.33 into 10 to the power minus 4. Since this didn't have any unit, will not give any unit to Kc also. Let's take the second one. Same thing, Kp is equal to Kc RT to the power delta n. Kp is what? 167. Kc is what we have to find. RT is 0.0831 is R. T is what? 1073 Kelvin. And delta n is what? 1. So you solve this, you get Kc as 1.88, and that is my answer. Since Kp didn't have any unit, I didn't give any unit to Kc also. The question says at 450 Kelvin, the Kp is 2 into 10 to the power 10. It's 10 to the power 10. 2 into 10 to the power 10 per bar. Is not 2 into 10 to the power 10 per bar for the reaction. This reaction, we have to find the Kc at this temperature. So if you see, Kp is what? 2 into 10 to the power. The formula is pretty simple. Kp is equal to Kc RT to the power delta n. Let's find delta n here. Delta n is what? Here we have 2. Here we have 1 plus 2, 3. That is minus 1. Right? The product side minus reactant side. This is 2, this is 3. So delta n is minus 1. Let's put the values. Kp is equal to 2 into 10 to the power 10 is equal to Kc into R, that is 0.0831. Temperature is what? Temperature is 450 Kelvin. To the power delta n, that is minus 1. You solve this, you get Kc as 7.48 into 10 to the power 11. Now the unit. See, since it was per bar, so it will be per m. M is what? Moles per liter. So if the unit of Kp is in bar, bar has to be replaced with moles per liter. So I wrote per moles per liter, or I can say that it's nothing but liter per mole. Same thing. Please note the unit you have to take care. So if it is if the Kc is in moles per liter, it has to be in bar. If it is moles per liter square, it will be bar square. If it is per mole per liter, it will be per bar. So every time mole per liter has to be replaced with bar. Correct? So in this case it was moles per liter to the power minus 1. So it was bar to the power minus 1. So it became moles per liter to the power minus 1. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.